Okay, today we're going to take some situations and we're going to construct useful diagrams for projectiles and answer some beginner SUVAT questions. We'll do some harder ones in a later video. So, a particle is projected vertically upwards. So for today, we are talking about something going up and then back down. Okay, that's going to be it. That's not how I'm going to draw it though, because that's not going to be useful. So from the ground, doesn't always have to be the ground, initial speed. Okay, so let's start drawing this one then. So here's the ground. I'm going to start right at the bottom here, and this is how I'm going to draw my diagram. So I'm going to draw it like this. Now, a few things to notice. That doesn't actually mean that the particle is going to go like this or anything. That's not currently what we're doing. The particle just goes, like I said, up and down. But this is not very helpful, okay? So we're drawing this because this is a visual aid to try and help us. Now, there are values of SUVAT, S-U-V-A-T, where there are lots of misconceptions about these. So the way that I normally would answer these questions is I tend to take up to be the positive direction. A bit more about that in a moment, okay? So I do up as the positive direction and I base everything around this. So the values that I'm consistently going to write in with SUVAT are U and A, and most of the time they will stay fixed throughout a question. So U, well, it says 12. I know it's a speed, but here the speed is the same as the velocity for that. It goes with my direction. What do I mean it goes with? I mean it like matches the direction. So if it matches the direction, it's going to stay positive and it's going to be just 12. Okay? What else? Well, projectiles are an example of constant acceleration. So there's a constant, there's a number that goes here. And it's related to gravity. Now, the problem, think about when something is in the air. Where does gravity want it to go? Well, it wants it to go down. So I'm going to say then that it's fighting my dominant direction, because once you pick a direction here, you know, these things are vectors. So, well, pretty much they're almost all vectors. So the direction's actually really, really, really important. If you get the direction wrong, everything probably going to be wrong. So I need to know that acceleration and the launch direction do not match. So that's why this must be a minus. So I'm going to write minus and minus G. G being the number 9.8, but it's often useful to just leave it like that. Okay, so these ones are actually the same all the way throughout the journey. So here, well, the start of this journey, U was 12. So U's still 12 and gravity is still gravity. Let's pick another point. Here, well, that means this journey. So it still started at 12. Gravity is still minus 9.8. In fact, even when I'm here, okay, yeah, that describes this journey. U was still 12, okay, A was still minus 9.8. So the U and the A are going to stay fixed throughout this journey. Well, how about the other numbers? Let's play around with that idea. So let's take this point, for example. What might the S number be? What might the V value be? What might the T value be? Well, at this point, S would be some sort of positive number. Let's use the right color. Some sort of positive number. How do I know that? I know that because S refers to displacement. It refers to this distance, but crucially, the distance that works with my direction. So this is above where it started. It matches the direction. So this is some positive value. Maybe it's, for example, like 5 or something like that. So S is going to be positive. How about V? Well, what's the velocity at this point? How is it moving at the end of that journey? Well, it's still going up. You can see it's still going up because there's more of the diagram to come. So this would be positive as well. And time, well, some time has happened in this journey here. Let's say t might be like 2 or something. It'll be some positive value. Okay, but these values for sort of S and V and T, they depend on where you are in the diagram. So let's say SVT at one point here, all of these values will be positive. How about here then? What will happen at this point here? So let's do S first. Now, what's happened with S? Well, S is the distance working with the direction above. S again here is going to be some positive number. How about V? How is it moving? Where's it about to go next? Well, this is an interesting point, isn't it? It's an interesting point because it's no longer going up, which would be a positive number, and it's not yet quite going down, which would be a negative number. So this would actually be 0 at this point. T, what's T? Well, again, T is some positive value because time has elapsed. So let's mark that one now on our diagram. So for S, V, and T, we would have the situation of a positive, a 0, and a positive. Let's pick another point. In fact, let's pick this point all the way down here. So the same again. S. S means how far away is it, vertically in this example, working with the direction. Well, remember, horizontally is not a thing. This is just a vertical question. So you're here, and then you close your eyes, and then you're back there again. What's the change? Displacement is the change. The change in this situation is 0. S does not take into account how far something has traveled. It just looks at before, after, and it has no idea about what happened in between, if you pick that point there. So that S point will be 0. What about V at this point? Well, V, lots of people like to say it's 0, but V refers to just the moment before it hits the ground. V is not 0. Which way is it going? It's going this way. That's fighting the direction. So at this point, V is a negative number. Okay, the directions for vectors are important. Time is an even bigger positive value. Even more time has elapsed. So how would I write this part here? So for this one, so SVT is going to be a 0. A negative number. In fact, it will actually be minus 12 because of symmetry. And time, again, well, time is always a positive number. So the idea we're looking at here is that some things tend to stay fixed, which is U and A. The reason for that is it's constant acceleration, and U refers to the start of the journey. Whether it's this journey, whether it's this journey, or whether it's this journey, all of those journeys have the same start. So we're now going to have a go one more time with the attached question over here. A ball is fired upwards from the ground. Okay, so here we go. We're not going to draw this because this is not helpful. We're going to draw this, even if that's not quite what's going on. It just said vertically upwards. So we're going to write down our SUVAT. Speed is 20. Well, as you saw in the previous one, if we make this our positive direction, it's quite useful to just lock that in and say plus 20 for most questions. A is against the direction. So in a lot of my questions, I have opposite signs on these ones here. So I'm going to write minus, I'm going to write equals, and I'm going to write a minus 9.8. The signs must be at the core of what you do. The signs are just as important as the values in projectiles. What else can we do? Well, we don't actually have any more numbers in this question, but we could complete some of the same analysis together. So some interesting things that happen. Remember, this will be the point where V is 0, because it's just in between going that way and that way. Okay, and in line horizontally is going to be the S equals 0 point. So when people say things to me like highest point, well, they're talking about this point here. So what I would do is I would put this is equal to 0, and now show that the time taken, hopefully you can see from there, it's showing me which equation I want to be using. Find out how long the ball stays in the air before returning to the ground. Well, the ground means here, doesn't it? So I would put like a 0 in. How long? How long? Okay. So when you know the different stages, this is really when SUVAT questions become much, much easier. So in the next video, we're going to have a look at when it's not from the ground to the ground. But I hope this gives you some sort of intuition to start with about how you label your projectile diagrams.